This problem involves discovering a coefficient of friction, kinetic friction, as a function of d, initial velocity, and theta, where you have a ramp, and on that ramp you have a mass with an initial velocity going uphill. Now there is a coefficient of friction, and in addition there is a angle theta with the horizontal that the slope makes. We also have one more piece of information, and that is that we know that with this initial velocity, the ramp, the mass goes up the ramp a distance of d. So this is distance d all the way to the beginning here. Question is, how do we find mu k? Well, what we need to do in order to solve this problem is we need to do a free body diagram. So if we analyze the mass on the slope, we end up having two forces going down the slope. One of them is mg sine theta, which is gravity, and the other one is the force of friction. Now the force of friction is actually equal to mu times the normal force, in this case mu k. But the normal force on a slope is equal to mg cosine theta. And of course that's actually the equal and opposite to the force of gravity. That's what the normal force is. So we can rewrite this as mu mg cos theta. Now some people think that there must be a force going up the slope, but there isn't. It's just an initial velocity that causes the mass to travel up the slope. So at this point we can write summation of our forces is equal to F net, which of course we know is ma from second law. So let's write down what our summation of the forces is. We have negative mg sine theta and also negative mu mg cos theta, and that's all going to equal ma. So now you see that in fact it doesn't really matter what our mass is, our mass ends up getting cancelled out, and we have an equation for the acceleration. Now how does that benefit us? After all, we want mu as a function of d, v, and theta. Well, we have theta, but what about d and v? Those are actually kinematics issues. And to solve a kinematics problem, we need to use a kinematics equation. And that equation is going to be vf squared is equal to vi squared plus 2a delta d. Now, when this mass goes up the hill, our vf is going to be 0 at the top of the hill. The vi, that's given. We know what vi is. And a, well, we just found that. So let's actually solve for a here. And we'll say a is equal to vf squared minus vi squared all over 2 delta d. But of course, we know since vf is 0, we know that this actually boils down to this. However, since we also have an equation for acceleration from up here, let's set those two equations equal to each other. So we have, in fact, negative, so we'll say, okay, a equals a. So that's negative g sine theta minus mu g cosine theta is equal to a, which is also equal to negative vi squared all over 2 delta d. Now, basically, we can solve for mu. All we have to do is isolate this term, and we're done. So in order to do that, let's actually multiply everything by -1, so we'll get positives. And let's take this term and take it to the other side. So in fact, it'll be negative. So we have mu g cosine theta is equal to vi squared all over 2 delta d minus g sine theta. Now you notice I did 2 steps in one. I actually multiplied everything by -1, and then I took this term to the other side, and it became negative. Now I'm going to divide everything by this term, and so I can say finally mu is equal to vi squared all over 2, and now I'm not going to write delta d, I'm just going to write dg cosine theta minus g's cancel